So in how many different ways can the following shapes be arranged from left to right? So who knows the answer already? 24? And why is that? Okay, so they all got a chance, they all could go first play or whatever in the first spot. So once one of them goes here, they all could go here, and there's 4 of them. Then there's 3 left once one of them is here. And it's counting backwards, multiplied out. And that would be 24 is correct. There's 24 different ways of arranging them from left to right. Okay, moving on to permutations and combinations. Lesson 10B, permutations and combinations. Tell whether each of the following is a combination or a permutation problem and then solve it. How can we talk about permutation and combination? They're completely distinct. Let's see. Am I going to make it complicated or permutation, combination? What is permutation and what is a combination? Permutation. This is like the example I have used before. What's this example I used to use before a lot? And let me see if I'll give it a shot in this first period. There's like a World Cup final, say. I'll talk about it. The World Cup final. That's if you like sports. I'm gonna draw a ball here for a soccer ball. The World Cup final. Then you got the Super Bowl. Can I draw a football? It's a football. So you got the Super Bowl, and your favorite team is playing. And then you got, what else sport? What else sport do you want to put in there? Baseball, a World Series. So a little ball. All right, here. How do you draw a little ball? This is a baseball. Oh no, they go like this or something. So here's what somebody's gonna give you as an example and tell you. They're gonna tell you, look, pick one of those 3 events: the World Cup final, or you could go to the Super Bowl. I already picked baseball. Man, I should have done basketball, huh? Whatever, baseball, I guess. So they go, hey, out of those 3, we'll give you the ticket. We'll give you a game ticket, and we'll fly you to the game. So pick one. Pick one out of the 3. Is that what I'm trying to do here? When you pick one out of the 3, so you're going to have a first and a second and a third. Pick one out of 3. Which one, who's going to go to who wants to go to Super Bowl? Super Bowl, anybody, Super Bowl. Nobody wants to go to Super Bowl? I'll give you a ticket for it. Super Bowl? There's like 10,000 now, $10,000. My friend tried to sneak into it. So, permutation is that order matters. Let me tell you, permutation order matters. If I say pick one, and you say the Super Bowl, and so the difference between the first and the second, where let's say that the second one, you get to stay at home and watch it. I'll say, hey, you don't have to come to class. You can just stay at home and watch it at home, and you get a free day. I'm gonna mark you present. But there's the difference between the first and the second is that, bless you. In the first one, you get to go watch it live. So if you actually get the first, it's different than the second. Whereas when I say a combination, where I say, hey, just choose two out of the three to stay at home and watch. Oh, if you choose football or the Super Bowl, and you choose the soccer, you choose to stay at home. You're gonna get a free pass to stay at home, and I'm not gonna mark you absent. There's no difference between these two that you picked here because you're just staying at home. Whereas when there's a difference between the first and the second, that's a permutation. There's order here. So the idea here is that when they're not the same value of them, then it is a permutation. All right, here, let's just move on. I don't remember exactly how I used to speak about this, but that's enough. That's good enough. Permutation is that order matters. Between the first and the second, there's different values to them. All right, let's go. Example A. In how many different ways can a be selected out of 36 choices for a school club? So some of you guys are in a school club, and you guys got the president of the club, president of the anime club, or whatever club. So you got the president. So we're going to put it in a ballot for a president, vice president, I think it is, and you need also the secretary. So in how many different ways can a president, vice president, and secretary be selected out of 36 choices for a school club? In how many different ways can we do this? That's just the warm-up problem. This is basically the warm-up problem. How many spots do we have? Well, how many spots do we have? No. You got 36 people in the club. And let's say in this particular situation, they all want to be president. This is just unlike this class who does not participate too much. But let's say that this particular club, they're all involved. They just love the club. They just love being in there, and they all want to be president. They all want to be vice president. They all want to be secretary. So in this perfect world, how many people could be president? How many people could be president? All of them. They all, and in this particular weird club, they're all just so involved in the club, and they love the club, and they all want to be president. They all could be president. And once somebody became president, how many are left over to be vice president? 35. And then after somebody's there, what? 34. So this right here is really the way we say it is 37 students in the club, permutation 3 spots. That's what really it is. 36 permutation 3. And 36 permutation 3 is because there's order. You got 3 spots, and 36 could be in those spots. So get your calculator, multiply that out. So it's a permutation problem because there is order in it. And 36 times 34 times 35 is what? Somebody get your calculator. I don't have one. Get somebody. 42,840 different ways. That's how many different permutations of that situation. Now, what's the difference between this one and the other one? Let me bring another. Let me give you another example about combination. you go to the pizza, your favorite pizza place, and then you go, hey, I'm gonna order a combination pizza. All right, you're gonna order a combination pizza. What are the options you got there? What are the ingredients? And so you go and they tell you the ingredients, and the high school student who works at the pizza place says, so we got these many. And then you say this to the person. You say, hey, okay, can you put pepperoni, and after you put the pepperoni, you put the jalapenos, and after you put the jalapenos, you're gonna put the pineapple. Are they gonna think you're kind of weird by saying all this? Why are you saying it like that? Why are you saying first you put the pepperoni, then I want you to put after on top of it you put this? Because you're telling them that there's order. You're saying, are you weird? Are you OCD? What's your problem? No, that's exactly how I like my pizza. On the bottom I want my pepperoni, then I then after you put. That's why it's called a combination pizza. Because you get the stuff and you throw it on there. And there's no order. You get it? So in a combination, there's no order. You say, what would you like on your pizza? Hey, throw some pepperoni on there, put some this and that. All right. Yes or no? You understand what I'm saying? So here we go. Choosing 3 students. Here's the example. I'm already saying choosing for combination. Choosing 3 students in a class of 24 students for the monthly cabinet meeting of the school. So what? He stopped doing it, Mr. Serta. He used to do it 3 years ago or something. Where he's like, hey, he'll just out of nowhere be like, what? And he's like, hey, teachers, can you send your representatives to the cafeteria? And I'm like, all right, here we go. Okay, who wants to go? Who wants to go? And it's the whole class. Me. Can I go to the meeting? And I'm like, you. And he's like, go. You go over there. You go over there. You go. Did it matter that I picked that person over there first, and then I went to this person and that person? Person is gonna be, oh, I feel special. He picked me first. There's no order. 3 of you guys go. Who cares? 1, 2, 3, go. When there's no order, it's not a permutation, it's a combination. So choosing 3 students in a class of 24 students for the monthly cabinet meeting of the school, it is a combination. It's a combination problem because there's no order. So when we do this combination, we got to get rid of the repeats. So the first person, second person, there's no distinction between them. So it is going to be this way of doing it. And this is my particular way of doing it. It's actually more complicated than this, but I try to make it as simple as possible. So it really is a permutation problem that needs to be get rid of these repeated repeats. So the way I'm going to do this, it is a combination problem, but we're going to go like this. It is 3. No. How many students are there in this class? How many students? 24. So out of 24 students, we're going to pick 3. It's a permutation that we're going to get rid of it and make it a combination by dividing by how many people you chose factorial. 3 factorial. That's it. So it's 24 pick 3 divided by 3 factorial. However many you pick. All right, here, let's do it. So the answer to this is going to be 24 pick 3. So how many spots do we have? We got 24 students in the class. And how many spots, how many people I'm going to go? How many am I going to choose? 3. So we're going to go 24, pick 3. Let's go ahead and do it like 24, pick 3. So how many could go that I could have chose? 24, then what? 23, then 22, 24, 23, 22. And then get rid of the repeats of these ones here. Of whoever I already chose, pick. It doesn't matter the order of who I chose. This person better not feel more special than that person or anything like that. So divided by 3 factorial. What is 3 factorial? 6, isn't it? 3 times 2 times 1, isn't it? Let me write down 3. No, I'm already 3. I'm going to go 3 times 2 times 1, which is 6. Go ahead and get your calculator, multiply that out on top, divided by 6. What is it? And the answer is 2024 different ways. And that is the lesson for today again. Pretty much that's it. So know how to differentiate between permutation and combination. All right, let's practice. Let's practice doing these permutation combinations. So we're going to solve the following permutation problems. Remember that for permutation, order matters. All right, let's go. So there are 4 students, and I'm going to pick 3 for 3 slots. Raise your hand if you already know the answer for 4, pick 3. You got 4 people in this particular situation, and then we got 3 slots. Come on. 4 times 3 times 2, 4 times 3 times 24. 4 times 3, 12 times 2, 24. Yes or no? This is, I'm giving you easy numbers, so we can do this quickly. 8 pick 2. Permutation. 8 pick 2. Oh, my peg came back. It doesn't do anything, all right? It's my peg. Where did he go? He left already. All right. What is that? 8 pick 2. Who has 8 pick 2? Raise your hand. Let's go. 8 pick 2. Loud. 56. Yes. You got 8 people. You got 2 slots. 8 times 7, 56. Number 3. You got 1 spot. They all couldn't go in that 1 spot. 6. 10 permutation 2. 10 permutation 2. 90? 90. 5 permutation 1. 5. 5 permutation 5. Pretty much you're putting your 5 ducks in order. 120. And let's do the combination ones now. So combination ones. So when we're talking about combination, there's less for sure. I could even have a test question where it says, which one has more? Does a permutation and combination have more distinct things that you can make out of them, and it's usually permutation, except very few that are the same. But it's all most of the time it's permutation. There's more of them than combination. So for 4 combination 3, it is 4 permutation 3, but then get rid of those repeats by doing that 3 factorial, or however many you chose factorial. So here we go. So really this is gonna be 4, pick 3, then get rid of the repeat 3 factorial. So that's how I do it. I don't even know, I haven't seen it on YouTube videos, and I haven't seen it anywhere else. This is just my way of doing this. So what is 4 permutation 3? 4 permutation 3 is 24, divided by what? Which is 4. Let's see if you can do everything in your head again now. What's 8 combination 2? Anybody? 28. 6 combination 1. This is what I'm saying, that sometimes they're the same. 6, isn't it? Because it's the same. Ten combination 2. 45. 5 combination 1. 5. 5. And 5 combination 5. What is it? It's 1. It's 1. Yeah. Okay, and then let's do some of these other weird problems. All right, you got it? Moving on. Permutations with repeated letters. How many different 8-letter permutations can be formed from the word tomorrow? So what's happening here is we have repeated letters. So some of these things are repeated, like O, O, O is repeated, and then also R and R is repeated. So you just have to get rid of those repeats again, kind of like what I just did. It is a permutation, so you do have 8 letters: 1, 2, 3, 4, 5, 6, 7, 8. So why don't we just go with 8 factorial without writing everything down? 8 factorial. There's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And then divide by the repeat letters. Is it only O and R? That's it, isn't it? Yes? So how many O's are there? So we're going to divide by 3 factorial. Is there, and then I said R is repeated. And so that's going to be 2 factorial. Times that by 2 factorial. So I could do this without a calculator. Let me try to do this without a calculator. So this 8 factorial is what? 8 times 7 times 6, 4, 3, 2, 1. Divided by 3 factorial is 3 times 2 times 1. And then I got 2 times 1. What I'm going to do is I'm going to cancel 3 times 2 times 1, 3 times 2 times 1. And I'm going to divide 2 times 1 is 2 into 4. That makes it 2. So that makes this 2. And now I just going to multiply this whole thing out. It still yeah, it still makes it. Go ahead and multiply 8 times 7 times 6 times 5 times 2, 5 and 2. What is that? That's what it is. 8 times 7. Or you could have just done 8 factorial divided by that. What is 8 times 7 times 6 times 5 times 2? What'd you get? $3,360 different 8-letter word permutations. And here's the last problem for today, 14. How many different 6-digit numerals can be written using all of the following 6 digits? It doesn't matter if you use letters or if you're doing numbers. It's the same situation. You got 6 digits. So you're going to do 6 factorial. And then look for those repeated numbers. So which number is repeated? 5 and 4. It's the same as this one, almost the same. Yeah, you got 4 twice, so it'll be 2 factorial. And you got 5 3 times, 3 factorial. And if I try to do this without a calculator, you would do 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. Shoot. 2 times 1 is 2. 2 going to 4. That makes it 2. 60. 60. This is 60, no? 60 different permutations. All right.